because we won't get time to do it all, but we'll get a start on it anyways. So we've already done one of these laws, haven't we? Which law have we done recently? Second law. Let's have a look at all three. So you're very important in physics if you have three laws. If you can come up with three laws, then that makes you important. Okay, so Newton had three laws. Kepler had three laws. Having three laws is a big deal. All right. You have that, yeah? Okay. Right, well, I'm sure some of you know it. So before I tell you, before you write it down, Newton's first law.
An object will remain in its state of rest or constant motion. Constant velocity.
Yeah, fine.
If it is not acted upon by a force.
Yes, that would do just fine. Yeah. So if a body is at rest, it will remain at rest, or if it's in motion, it moves with uniform velocity, or as you said, constant velocity, same thing, until it is acted on by a resultant force. Now you don't, listen, for the exam, you don't need it word perfect, okay? What's the key words or points that we would need to have in our definition? They would definitely want to see you say something about rest. And what else? They definitely want to see something like uniform velocity or constant velocity, right? And what was the last thing they would want to see?
Resultant force.
Yeah. But I might even say they might want to have a word. You must have some word like until. Do you know what I mean? Like a condition.
Unless.
Yeah, unless, until, something like this. These things work much better if you can remember them in your own words. Do you know? It's okay, Harry? Yeah. You know, I had Jeffrey and Son in the English class earlier today. Yeah. And I was shocked. Jeffrey gave me so many answers. So many. Like usually in physics, he's very quiet.
Yeah.
And then in the English class, he must have gave me 7 or 8 good answers. So, I don't know. He's more talkative now in English class. So now, Harry, you're the quiet student in class. It was Jeffrey, he was quiet. Now you're the quiet student. Regina's not so quiet. You were talking quite a bit today, so that's good. You were telling me about your problems with question 5, so that's good. I'm happy with that. Maybe, Harry, you're so quiet because it's too easy. You can say yeah, that's okay.
I already learned it before.
Okay, yeah. Did you learn it in English?
No, but in English.
Ah, okay, all right.
I can't understand.
It's not so different. Yeah. How are the Vietnamese words? Are they similar or totally different?
They're quite similar.
Really? Okay, yeah. Because he learned it in you did it in Spanish.
Yeah.
So in Spanish it must be very similar.
Yeah.
Yeah.
I mean, some things, like the majority of it.
Majority would be similar. Yeah, yeah. Okay. Now, here's a good example of Newton's first law, roughly speaking. So an object will at rest will remain at rest. So a football, if it's not moving, it won't start moving. Unless acted on by a force. In this case, the force is from the foot. Yeah? It will continue in constant velocity unless acted on by a force, in this case the net. Now I know this isn't 100% real life, perfect, because Is this moving at a constant speed in this picture?
No.
No, what's happening to it?
It's
Gravity, yeah, drag,
Correct.
many things happening to it, but roughly it gives you a good idea of the law. Okay. Now, Newton's second law. Force is the product of mass and acceleration. That is F equals ma. You got that? Yeah. Now, please note, this is very important. Are you all listening to me? There are two definitions of Newton's second law, okay? There are two ways to express it. The first way is this way. There is another way which we'll learn about later. In the exam, they don't want this definition because it's too easy. F equals ma. So can you make a little note beside this? Just write something like, this is not the exam definition.
Didn't we do it already, sir?
No, I think the last time we did this, we just said Newton's second law is F equals ma.
No, we did it. Force is what changes the motion of an object.
Oh no, that's not. Oh, sorry, that's not the technical. That's only the definition of the word force. That's not Newton's second law.
Okay.
There's no equals in that.
Yeah.
You
It's
know.
isn't it the opposite? The bodies.
Oh, that'd be
When
Newton's
it-
third
when
law, I
it-
think.
Oh, yeah, when a
Yeah.
force is.
Yeah, but that's the next
Doesn't
one
the
then.
second one have to do with momentum?
Yeah,
Yeah.
the alternative definition is related to momentum, which we'll do in a later lesson. Okay, do you have that note? Regina, you wrote that? Yeah. This is not the exam definition. Okay, continue. Okay. That's a picture, I guess, of force, whatever, I don't know. Right, Newton's third law. Now, who wants to try and give me Newton's third law? So you gave me the second one. Well, let's see if anyone else can give me the third one then. No, you don't want to even try. Okay. Regina, do you know the third law? Yeah. Good. Good. Yeah. Close.
Resultant force of two.
Okay, go on, go try. It's not really about resultant.
Like
Yeah.
When there's a force acting on one
Yeah.
one surface,
Yeah.
then there is always a force of the same magnitude acting on that.
That will do just fine. Not very elegant, but it'll do just fine. What were you going to say? Do you have something similar or something different?
When an object exerts a force on
On B, yeah.
Object B, object B exerts a force
Mhm.
equal in magnitude but opposite in direction onto object A.
Yes. Okay, that's also fine. I've seen that definition before. The easiest, yeah? No, go on. No, that's Newton's first law. Yeah. The easiest version of Newton's third law is quite simply, for every action, there is an equal and opposite reaction. That's the simplest way to put it. Wait. Before you write it down, I'm not quite happy with the word and here. I think it would be better grammar if you can change it to but. No, maybe and. Doesn't, who cares? Whatever. Doesn't really matter. It's equal in magnitude, right? But opposite in direction, yeah. You know, I don't think that's a bad idea. If you want in your definition just to write a little note above equal, like a little arrow, you can write in magnitude, and then underneath opposite you could just write with a little arrow in direction.
Parenthesis.
If you have space, that would be great. Yeah. Yeah. Okay. Continue. You all have that? We'll get to that. Don't worry. Yeah, we'll do examples now. So here's a good example of Newton's third law. A simple little example. So the air is pushed out of the back of the balloon. That's the action. And the reaction is the balloon is pushed forward. Now you can also think of this in terms of, like you said, A and B. So the A that's coming out the back, that's the exerting a. It's almost like the balloon is pushing the air out the back, and the air is pushing it forward. Like there is the exerting in both directions. The other example, I think you were talking about surfaces. So the example always is with the wall. You know, you push against the wall, and the wall pushes back. Or with the table. You know, something is resting on the table, there's a weight, but then there's also an up force. Yeah. So this is the simplest example that explains the concept. So the action is the air comes out the back, and the reaction is that the balloon moves forward. Is that okay? Yeah. So here, these have names. The down is called the weight. But the reaction upwards is called the reaction force, or also called the normal force, because it is perpendicular to the surface of the table. So the reaction force is the force provided by the reacting object. In this case, what is reacting is the table. The table is providing the up force. Because if you think about it, if I put this cup here, there's a weight, isn't there? But the weight is still there, but the cup has stopped moving. Oh, that's because the table has a force upwards. Yeah. So this is called a reaction force. You got that? Yeah? Yeah? You have that? Okay, so look, the next half of the lesson is the examples, and I've got quite a few examples. I've got, oh my goodness, 1, 2, 3, 4, 5 examples. So I think what would be much better is if in the next class I do the 5 examples, and then just leave it there. This seems like a natural end of part 1 to be continued in part 2. Right, I'll leave it on a cliffhanger. You know, how is this going to be solved? What's going to happen next? Who knows? But we'll leave it there anyways.